Okay folks, last time we spoke about multi-touch and we showed visual feedback on my phone screen, an actual working example. Today we're just going to build on that and we're going to talk about scaling and rotating. So as usual, I'm going to start a new scene. I want to copy this code. So let's say Control A, Control C, and I'm going to use that code for the new scene that I'm going to create. So let's create a new scene here. We can close off the scene. And this scene will make it a 2D scene as well. Let's name this Scale Rotate Scene. Let's save that. And let's add a script to it. Control V to paste. So this is going to work exactly like the last example. Let's remove the print statements. We don't need these anymore. So let's delete, delete, delete. And maybe change the color so we can see the difference. Maybe some sort of blue. A lightish blue maybe. Dodge blue looks nice. That will look good on a dark screen. And let's save this. And of course we need something to scale and rotate, so let's just add something here. Let's just add a sprite 2D, and for the sprite 2D we'll just use the Godot icon, drag it across, put it here, and let's just move this to the center in the screen somewhere visible. Let's go back to the script. Let's initialize the sprite 2D at the beginning so we don't have to keep referencing it directly. So let's say onReady variable, and let's give it a name like sprite. You can call it whatever you like. Is equal to, and we'll just drag it across. So it'll be much easier to reference a sprite, and the onReady statement here tells the compiler to make sure that the sprite 2D or whatever we're using after onReady initialized before any other statements in the code. And here I just want to add a few more variables. One like start distance. And our start distance, let's just say 0.0. Variable of a start angle. Let's do another variable here. Let's call it initial scale. Of course, the initial scale should always be 1 unless you have another reason for not letting it be 1. And the initial rotation, which should be 0 because we don't want any rotation initially. And let's save that. Okay, let's widen the screen so you can see what I'm doing. Minimize the output. After we've done all this input, all these if statements in the input here, we'd like to probably check the number of fingers, the finger count. So let's go down 1 and just leave another space, just go back 1, and let's make a descriptive function here. Let's call it finger count check. And of course we have to create this function. So let me go to the bottom of the code and create a function called finger count check. And let's just put pass for now. So here we want to check for, it's going to be scale and rotate, so we need 2 fingers at least. I'm just going to stick to 2 fingers. So we're going to check to see if it was 2 fingers used. So if touches, which is a dictionary that I created earlier at the top that I copied from the other code, if the size of that is equal to 2, so if it's 2 fingers or 2 points or 2 touches, we want to do something. So we're going to create an array called points or fingers, whatever you want to call it, and let that equal to touches dot values. So in our case, we just allowing for 2 touches, so this is supposed to show at least 2 points, 2 vectors, 2 positions on the screen. We're just allowing for 2 touches, and touches dot size is equal to 2. So point is only going to give us arrays of 2 different positions, touch positions. And for simplicity's sake, I'm just going to create 2 other variables, point 1 and point 2, p1, p2, and we're going to call p1 point 0, which will be the first index, and p2 will be points 1. It's going to make it easier to just type in p1 and p2 when we're doing calculations later. So we detect 2 fingers, else if it's not 2 fingers, we're just going to reset start distance will be equal to 0. Okay, so now that we have the finger count check function in place, let's go back to the inside here and do something with the p1 and p2 values that we're going to find during touches. So I mean, leave another space, and let's say variable current distance. Just give it any name that is descriptive enough for you, is equal to, and this is an inbuilt GD script function, p1 dot distance underscore 2 open brackets p2. So basically this function distance 2 calculates the distance between p1 and p2 using Euclidean calculations, which is similar to Pythagoras theorem. So now we have the distance between the 2 points. What are we going to do with it? Let's just create another function, make life easy. Everything is modular, so it's easy to go from point to point. Let me call this one calculate scale. So we're going to calculate the scale with this information that we have here. And of course, we have to create a whole new function called calculate scale here at the bottom, or wherever is more convenient to you. But we may need this information here, this current distance, during calculation, but it's not available outside of the finger count check function, so we can just pass it in as a parameter. So let's put current distance. So now calculate scale will require a parameter in here. So let's just, the function that we created, let's just put a parameter in here and call it cur distance, or cur dist, and all errors should be gone. Okay, we're going to do some checks here now. So we want to check if the start distance is equal to 0. Don't forget colon. We're going to set the start distance to the current distance. this curdist accesses the value that was passed in earlier inside the finger count check around over here into calculate scale. And our initial scale, we deal with scale, will be equal to the scale of the sprite that we're using. So let's just do sprite, which we initialize at the top here, variable sprite 2D, sprite dot scale, and let's just use one axis for now so that we could have uniform scaling dot x. Else, if we have some movement between the two fingers, we want to calculate a scale factor. So let's create a new variable here called scale factor. Basically, the scale factor is the distance, the new distance between the two fingers from the old distance between the two fingers. So scale factor will be the current distance divided by the start distance. So if the current distance becomes bigger than the start distance, you're going to get a greater value for the scale factor, and we're going to use that to scale up the sprite. If the current distance is less, like if you're pinching the two fingers, that means it's going to be smaller than the start distance. We're going to scale down the sprite or zoom out. By the way, zoom in is when the sprite gets larger, because you're zooming in. If it's a map, it's like you're zooming in to see what's going on inside the map, and zoom out is scaling down. And now we're going to use this information, the scale factor, and let's scale the sprite up. Sprite dot scale will be equal to the initial scale multiply by our scale factor that we just calculated. But of course, this gives you a float value, but scale is usually calculated in vectors, vector 2. So we need to, well, in this case, in our 2D program, it's calculated as a vector 2. So we need to multiply that by a vector to give you a proper scaling of the x and the y. So let's multiply that value. If you want, you can put these two into brackets, the initial scale and the scale factor. And let's just create a new vector 2 here, dot 1. This is just basically x is 1 and y is 1. So whatever you multiply in there, it's going to create a vector for you to use, which scales x and y uniformly. If you like, you can do it separately to get different types of scaling, but I'm just going to deal with uniform scaling here. Let's save this, and that's it for scaling. There are many other tweaks you can add later on, but I'm just going to do the basic scaling here. And of course, don't forget to change in the project settings. This is a scale rotate scene. And let's run it on my phone. Okay, it seems to have started on my phone. Okay, so there we go. I'm going to touch with two fingers, and if I move in between the two fingers, you'll see we zoom in out on the icon. If I move out, you see we zoom in into the icon. Let me just get a little closer and let's do it again. Yeah, so it works. And of course, for rotation, it's going to be similar, just different calculations. So let's go back up to our finger count check, close off the output, and just below the calculation for scale, let's put a variable current angle, and this will be equal to this calculation P1, or you can do P2 minus P1, but whatever you use, make sure it's consistent throughout your code, P1 minus P2, and dot angle, a built-in function, dot angle, which calculates the angle between, when you do your calculation between the P1 and P2 vector, the angle between the resultant vector and the x-axis will give you this current angle, and we're going to use that angle to do our calculations. So let's just create a new function and call calculate rotation. And of course, again, we want to pass in the current angle, just like we did with the current distance. And let's go to the bottom and create that. And let's type function, func, calculate rotation. And we need to input something here. So let's call curl rot. And here we're going to test again for if the start angle is equal to 0. Remember, this is all in radians. Don't forget colon like I did. We're going to set the start angle to the current angle, or current rotation as it's called here, and the initial rotation to the rotation of the sprite dot rotation. Of course, similar to the last function, else create a new variable and call it rotation change or something similar, whatever works for you. Programmers like to call it rotation delta. That rotation change will be equal to the current angle that we use, the current rotation, sorry, that's the name I use, minus the start angle. And that will give you a difference of the rotation in radians, which we can apply now to the rotation of the sprite dot rotation is equal to the initial rotation plus the rotation change that we just calculated. And that's supposed to work as is. Let's save this and let's test this on my phone. So this is starting on my phone. Here we see the sprite. If I put two fingers and I move apart, you get a scaling. And you notice if I turn my fingers relative to each other, you get a rotation. And this works as intended. Of course, there's little jitters and movements of my finger. And as soon as I touch, sometimes you get rotation. If you want, you can actually put threshold values for rotation and scaling that will prevent scaling and rotation when the fingers move by very little values. If we want to add some code, let's lower the output. If we want to add some code to minimize jitters and slight finger movements, we can just add some sort of threshold here. So like, let's say for the scale, just after we calculate the scale factor, we can say if, and let's use something called absolute, ABS, that calculates the non-negative number. So if the value you get is a negative value, it's going to give you a positive value of that. So if it's -1, you get 1. If it's -1.5, you get 1.5. Basically, we're just going to check the absolute scale value, scale factor that we calculated here. Let's just -1 from that because the scale starts at 1. Remember, we set the initial scale to 1. So it starts at 1, so we minus in 1 to find out how much of a difference occurred in the movement that caused a scale factor between the two fingers. And if that absolute scale is, let's give it a small number, let's say 0.01 maybe. If you put too much of a big number, it's not going to register a change in your finger movements easily. So let's just put 0.01 0.01 colon. So if your absolute scale factor minus 1 is more than 0.01, tab here, and we'll get a movement. If it's less than 0.01, you're not going to get a movement. So any little tiny movement in your fingers is not going to trigger a scale. Same thing here for the rotation. Let's put if, and again the absolute, we want absolute values. If the absolute rotation change, now we don't need to minus anything from this, because a rotation change is basically what angle already occurred. If you actually had a rotation change, if the absolute rotation change was more than, let's say, 0.1, we're going to rotate the sprite. If it's less than 0.1, we're not going to rotate the sprite. And let's try this out. Okay, so it looks like my phone is ready. If I put my two fingers, any slight movements, it doesn't affect the node 2D. Well, sorry, it doesn't affect the sprite. If I move out, if I move my fingers out, and I move my fingers in, you can see that everything is moving smoothly, except now and then you have a little jump in your rotation because the change in rotation didn't kick in. That can be fixed by using loop angle specifically, but I'm not going to use that here. But loop angle, basically what it will do, it will smoothen the movement between the initial rotation and the target rotation by some factor. But as you can see, this works. As soon as I touch it, there's no more jittering when I'm scaling and so on. I hope this is informative, and I hope to see you in the next video.